So let's say we had these two groups of numbers. One is heights of women. And one is weights of men. And we talked about how to make a conclusion about which group in its entirety has more variation by comparing coefficient of variation. But let's say what we do now is we take one number or one person from each group. For example, let's say we take a woman who is 6 feet tall versus a man who is, let's say, 180 pounds. And we want to know which person is considered more typical in their respective group. Is the woman who's 6 foot tall, is she more typical for heights of women, or is the man who's 180 pounds more typical? So how do you think we can quantify and conclude that?
Using standard deviation.
Okay, so how would we do that?
So with heights of women, it would be 2 standard deviations from the mean. With heights of men, it would be less than 2 standard deviations from the mean, therefore 180 pounds would be more typical.
Okay, excellent. So let me build up to that. So this woman who's 6 foot tall, first of all, we're trying to answer the question of which person is more typical. So more typical is going to be the person who's closer to the mean. The person who has a value that is closer to the mean value is considered more typical. So the question is, how do we gauge how far somebody is from the mean? So if you take this woman who's 6 foot tall and you just subtract the mean value of 5'6", then the distance is going to be 6 inches. So that'll be the distance from the mean. Is going to be 6 inches, and likewise, the distance of the man who's 180 pounds from the mean of 170, his distance from the mean is 10 inches, or 10 pounds. So this is the distance from the mean in both cases, and the one who's closer to the mean is considered more typical. But how do you gauge closeness? Can you just compare 6 inches to 10 pounds? And say the woman who's 6 inches is less, a number that's less than the man who's 10 pounds, so therefore she's closer to the mean and she's more typical. No, you can't do that because one is in inches and one's in pounds. So you have to normalize this distance somehow first, and the way we're going to normalize it is to convert this distance into standard deviations. So the woman who is 6 inches away from the mean, how many standard deviations is she from the mean? 2. Yeah, so because there's 3 inches in one standard deviation, so therefore, if she's 6 inches, she's 2 standard deviations away. And the man who's 10 pounds away from the mean, how many standard deviations is he from the mean?
2/3.
Yeah, so the same process we did before, which is we took this distance and we divided by the number of units in one standard deviation. So same thing here. We're going to take this distance of 10 pounds and divide by the number of units in one standard deviation. So this gives us 10 over 15 standard deviations, which is 2/3. So now we can compare the number of standard deviations from the mean directly. And because the man is less number of standard deviations away from the mean than the woman is, the man will be considered more typical. The man who weighs 180 pounds is more typical. Any questions? So what we just did, we converted each distance from the mean in terms of the number of standard deviations from the mean, and we call that a z-score. So each of these numbers here is a z-score. So the z-score of a data point is simply the number of standard deviations that that data point is away from the mean. And in each of these cases, we were able to calculate the z-score, or the number of standard deviations from the mean, by simply taking the data point, like the woman who's 6 foot tall in this case, and we subtract the mean. And once we get that, we divide by the number of units in each one standard deviation. And that's how we got the 2 standard deviations for the z-score. So let's generalize all this. So let's say that the data point is x. Let's say that the mean is given by this symbol for the population mean. And let's say that the standard deviation is given by this symbol for the population standard deviation. Let's come up with a formula together to find the z-score of the data point. So based on what we just did, we're going to take our data point x, subtract the mean. That'll give us the distance from the mean in units. And then how do we convert this to the number of standard deviations?
Divide.
Yeah, divide by the number of units for each one standard deviation. So it's dividing by this number of standard deviations. So this is the formula for the z-score. And you'll see this over and over in this class. But it's really nothing more than just finding the number of standard deviations that a data point is away from the mean. Any questions?